All right, today we're going to talk about 7.3, which is talking about the angle-angle postulate to prove similarity in triangles. So what the angle-angle postulate says, if two angles of one triangle are congruent to two angles of another triangle, then the two triangles have to be similar. So if you take a look in its simplest form here, if you have a triangle here, this has 52 degrees, and this one has 52 degrees. But this one says 88 and this one says 40. So you can't really tell if those two are congruent or not. I'm going to make this a little bigger. Whoops. Sorry. You can't tell if those are congruent or not until you find the third angle. So if you take your calculator, you know that all the angles have to add up to 180 degrees. So you could just take your calculator and say 180 minus 52 minus 88. And you know this third angle here, this one here is 40 degrees. Well, I see this other triangle has 40 degrees. So now I know that I have at least two angles that are same. I have 52 and I have 52 and I have 40 and I have 40. So that's enough information to say that these two triangles are similar because of angle-angle. Because you'll find out if I take 180 degrees and subtract 40 and 52, in fact, I'll get 88 degrees, which is exactly what this angle is over here. So you can go ahead and see that this here is going to be similar. So let's take a look at a few of the examples, and I'll work through them with you. So let's take a look at number one. It has triangle ABC and triangle DEF. So I see that it has two symbols that look like this. And if you remember, that symbol means that it's 90 degrees. So I know these two angles are congruent. And this one is 30 and this one is 30. So I know they have two angles that are congruent. So I know that these two triangles are similar because of the angle-angle postulate. And it's said to write a similarity statement. So when you write a similarity statement, you put the little triangle symbol and you write the first triangle in any order that you want. I just wrote ABC because it seemed to make the most sense. And then you put similar. And then you have to match up the congruent angles. So I started here with angle A. Angle A is my 90-degree angle. So I have to go over here to my other 90-degree angle, which would be angle E. Then I went to angle B. Well, B is an angle that's not marked at all, so I have to go over to D, which is my other angle that's not marked at all. And then C is my 30-degree angle, and that corresponds to F. So I have triangle ABC is similar. Remember, this little squiggly sign means is similar to triangle EDF. So why don't you do number 2 and 3 on your own and see how you do, but let's do 4 together. So here I have a triangle. It has 95-degree angle and a 62-degree angle. Well, this one has 157. So I don't have either of these two that match up. I can take my calculator and find the third angle. I could say 180 minus 95 minus 62, and I'll find out that this angle here is 23 degrees. And I can do the same thing for this triangle. I can say 180 minus 57 minus 100, and I find out that this angle is also 23 degrees. But it's not enough to have only one angle that's congruent. You have to have at least two, so these are not similar. All right, let's take a look at the next page. So here, this page is a little trickier because now they've kind of nested the triangles together, and you have to use some of the information that you learned previously in geometry to figure this out. So this one says, given that AE bisects angle BAD, is there enough information to show that the triangles are similar? Well, first of all, you have to kind of remember what that word bisects means. It says that this segment here, AE, bisects this angle here, BAD. So if you remember, the word bisect means that it breaks it into two equal pieces. So that means that this angle would be congruent to this angle. I don't know what its measure is, But I don't really need to know what measure it is. I just need to know that they are congruent. Well, now in this little triangle ABC, I know that 78 is congruent here to this 78-degree angle, and this angle is congruent to this angle. So I know that, yes, these are similar because of the angle-angle postulate. So if we look at this one here, number 5, it tells me that KN, remember this means is perpendicular to JM. Well, remember that perpendicular lines form 90-degree angles. So if this KN is perpendicular to JM, that means that this is a 90-degree angle and that this is a 90-degree angle. Well, K is congruent to M. That's what those little tick marks mean there, that those are congruent. And this is 90 degrees and this is 90 degrees. So I have enough information to say that they are similar. Now that I know they are similar because of the angle-angle postulate, I can write a similarity statement. Triangle, I'll write K and J is similar. Remember, that's the symbol for is similar to. Triangle. Well, I started with K, so I have to go to M. And N is N on the other side. And J would be similar to L. So that would be my similarity statement. On number 6, they tell you that QP is parallel to ST. So now you kind of have to go back to what you remember about parallel lines cut by a transversal. Remember, this line that cuts them is called a transversal. And I know that alternate interior angles have to be congruent. So I know that this angle has to be congruent to this angle. Well, these angles in here are vertical angles, so I also know that they are congruent. So I have proven that two angles are congruent, so I know that these are congruent because of the angle-angle postulate, and then you can go ahead and create your similarity statement. On example 3, this one's a little bit trickier. This is a little trickier to see. I'm going to see if I might do this in some different colors to see if that helps you. So this one here, they tell you that this is parallel to this one here. And so if this is cut by your transversal, so if you kind of focus, those are your parallel lines, that's your transversal. If you remember, corresponding angles are congruent. So I know that that angle is congruent to that angle. But then it also tells you that these two lines here are parallel. And if I still use this as my transversal, then corresponding angles are also congruent. So I know that those two are congruent. So I can prove that these two are congruent because of the angle-angle postulate. But then it says, find the value of x. So now I'm going to, now that I've proven that they're similar, I can write a ratio. So I know that this side corresponds to this side. So I can say 16 over 10 corresponds to this side over this side equals 24 over x. Now you can see in the example, they did the same thing I did, but it's upside down. It doesn't really matter which way you do it, as long as if you start with this triangle, you go to this triangle second. They started with this triangle and went that way. Same thing. Because you can see when I cross multiply, I'm going to get the same equation they did. I'm going to say that 16x equals 240, and then you're going to divide both sides by 16, and you'll find out that x equals 15. So now you have solved for x. Okay? So see if you can set this one up. You know that these two are similar because they have two angles that are congruent. And when you're trying to find the variable, the value of the variable, what I always do is you always say this side is between the 1 tick mark and the 2 tick mark. So 20 would correspond to the side that's between the 1 tick mark and the 2 tick mark. So 15. And that would have to equal this other side, which is between 2 tick marks and no tick marks, 12, over 2 tick marks and no tick marks, which is x. Then you can cross multiply. You can say 20x equals Take out your calculator and you can say 15 times 12 will be 180 degrees. 180, not degrees, sorry. And then in order to solve this equation, you're going to divide both sides by 20. I'm running out of room a little bit. And again, you just say 180 divided by 20, and you'll see that your answer is 9. On this one here, you might have to break this up into two similar triangles, but you're going to see in the next lesson, if these two lines are parallel, it's going to break these sides up into proportional pieces. So you could say 5 is to y as 15 is to 12. Now that's only going to be true for the sides, so not this base here. You can't use that, but this side would be proportional to this side as this side is to this side. And then once again, you can cross multiply. 15y equals, again, if you don't know what 12 times 5 is, just go to your calculator. 12 times 5 would be 60. And then to solve this, you're going to divide by 15. 60 divided by 15 will give you 4. All right, so let me know if you have any questions on that.